Hello, everyone. Today I'll be presenting on the materials and methods section for the article Applications of Phytol Compounds to Reduce Acrylamide Levels and Increase Antioxidant Activity of French Fries. So the main aim of the study was to examine the effects of phytol compounds, specifically glutathione, cysteine, and N-acetylcysteine on the color, antioxidant activity, total phenolic content, ascorbic acid content, and acrylamide content of French fries. So first, the samples were gathered and prepared. The potato tubers were harvested at maturity and stored at 10 degrees Celsius until the frying process to preserve their quality and prevent the formation of reducing sugars. And the sunflower oil used to fry potatoes was also sourced locally. So once retrieved, the potato tubers were washed, peeled, and cut into 9 by 9 millimeters sticks using an industrial slicer, followed by a ruler and a knife to ensure that the six sticks were 5 centimeters in length. Sticks were then rinsed with tap water for a total of 30 seconds to eliminate any starch materials that may be on the surface to prevent the mobility of the surface water, resulting in soggy fries. So there's our sticks. Some of the sticks were the pretreatments were created for the 5 sample groups that were used, contained concentrations of glutathione, cysteine, and N-acetylcysteine, as well as a sodium metabisulfite that was used as the positive benchmark, and an untreated concentrated for control. And then the concentrations for the glutathione for the phytols were 0.5, 1, and 2%. And they were prepared at 25 degrees Celsius to observe the effects of the different concentration levels on inhibiting acrylamide. And as previously stated, the sodium metabisulfite was served as the positive benchmark. So how the study was done was that they took 100 grams of potato sticks and they were randomly selected and they're immersed in each concentration at 300 milliliters of the corresponding solution for 1 minute to allow the treatments to absorb. And the potato sticks were then allowed to air dry for 1 hour to ensure that the samples were entirely dry before frying. And then all of the experiments were run in triplicate, meaning that it was conducted 3 times, which allowed the authors to observe the statistical significance of the results. So for the frying conditions, the 100 grams of potatoes were fried in 1 liter of sunflower oil to create a 1:10 ratio. The sunflower was changed to ensure freshness between each sample frying process. And the fixed temperature used in this experiment was 180 degrees Celsius to mimic realistic frying conditions seen in residential and commercial practices, as well as due to the fact that acrylamide formation occurs in temperatures above 120 degrees Celsius. Durations of 3 to 4, 6, and 8 minutes were examined to determine the optimal frying time of the potatoes. And determining the optimum frying time and temperature for the French fries can ensure the processing conditions at which the products will maintain its highest quality, while also still being able to lower the acrylamide content. And the optimum frying time for this oil temperature was determined to be, or optimal frying time for the French fries was determined to be 6 minutes, as no significant changes in surface of the French fries were observed. And then a data logger and a K-type thermocouple were used to measure and record the oil temperature conditions and any changes that may have occurred every 5 seconds. By doing this, by monitoring the temperature, it'll help prevent any significant fluctuations in the oil between the frying processes and guarantee that all samples will be fried at the same established conditions to allow for the proper evaluation of the effects on the compounds of the phytol compounds on acrylamide. So for the color analysis determination, a PCE colorimeter was used to measure the light reflected off of the samples. And a colorimeter is a tri-stimulus, which means it's a 3-filter device that utilizes the filters based on the specific parameters being studied. And it basically mimics the way that our human eyes are able to perceive the color. And for the specific study, the selected spectral parameters measured were lightness, redness, and yellowness. And the authors were able to calculate the total change in color using this formula. And it was used to calculate and determine the total change in color observed in the French fries. And C denotes the color change observed in the French fries values immediately after cutting, while F denotes the values measured immediately after frying. So for the determination of a residual file content, the changes in the content of the samples were measured by first defatting the fries to remove the unwanted fat components that we don't want in this extraction. And then 1 gram of each sample was homogenized with 5 milliliters of serine borate buffer using a tissue terroir. The purpose of this tissue terroir is to rapidly homogenize, break down, and emulsify the sample together. And the mixture was then placed in the centrifuge over here in order to separate the solution based on the different densities of the molecules, thus meaning that the lower densities will be on top and the molecules that have a higher density will go to the bottom. And the collected supernatant were then diluted and derivatized using an NPM, as it will be able to react with the free sulfhydride groups to form fluorescent derivatives. And then the solution was then incubated for 5 minutes, followed by the addition of 10 microliters of 2NHCl. And the 2NHCl is added in order to stop the reaction. The solution was then filtered using a nylon disc, which we have up here on the system, to remove any small unwanted components. And the sample of the potato was then injected into the high performance liquid chromatography system, or the HPLC, located here. The one used for this specific study was Hitachi. And the HPLC polar column contains a stationary phase contains packing material made up of porous silicone beads and synthetic resins. And a high pressure pump, which is the nonpolar mobile phase in this study, they used a 70% acetonitrile and 30% water solution, is pushed through the column. And when this happens, the components of the potato sample interact with the absorbent materials, causing varying elution rates, which will then lead to the separation of the components as they flow out of the column. Okay, so for determination of antioxidant activities and total phenolic contents, the study was conducted by taking 2 grams of the potato sample and then homogenizing them with the tissue terroir with a combination of 3 milliliters of methanol water. And the principles were the same for the tissue terroir. The samples are then able to go through sonification with the purposes of using sound waves to agitate the particles in the potato solutions, and that then they're able to break down and are free to enter into the solution. So that's our system right here. And then centrifugation is completed to collect the supernatants, and an additional 3 milliliters of the methyl sulfate is added to repeat the process all over again. So then the supernatants from these 2 extractions are combined and they equal a total of 10 milliliters. And then after that, we're able to conduct the 4 tests that we were planning to do. DPPH, scavenging agency for reducing antioxidant power, cubic ion reducing antioxidant capacity, and total phenolic content were then determined using the system. DPPH scavenging activity is used to screen for antioxidant activity in the potato samples. FRAP measures the antioxidant capacity of the potatoes as they are able to contain phenols. And then CUPRAC measures the copper-2 reducing ability of the polyphenols that are present in the potatoes. While the TPC is used to measure the thione cytosine assay with the oxidation of phenolic compounds producing a colored product. And the spectrophometer is used to measure the light absorbance of the solutions. And this is done by the light beam passing through the sample, and it will then absorb or reflect at a specific wavelength. For the determination of ascorbic acid content, was determined by combining 2 grams of the sample with 10 milliliters of a metasorbic acid, and then homogenizing this mixture with the tissue terroir. The mixture was then centrifuged for 15 minutes to collect the supernatants, which was then transferred into smaller tubes and centrifuged again for 10 minutes. The solution was then filtered using the nylon filters previously mentioned in the study, and then was injected into a reverse phase HPLC system And basically what that means for a reverse system is that the column will be nonpolar, and the folic acid that was used will serve as a polar mobile phase. For the extraction of acrylamide, samples were initially freeze-dried at -50 degrees Celsius for 24 hours using a lyophilizer. Lyophilization is typically used to remove the water that's present in our products to help preserve and extend the shelf life of perishable materials. And it's conducted in 3 phases, the first being rapid freezing, which is done to prevent the formation of large crystals. Next is sublimation, which occurs to convert the ice directly into the gaseous state by lowering the pressure using a high pressure vacuum and slowly adding heat. And then finally, absorption removes the ionically bound water molecules found in the product by raising the temperature higher than the primary drying phase, which is sublimation. Samples were then ground up, and acrylamide extraction occurred by adding 9.5 milliliters of 10 microliter formalic acid, 0.2 milliliters of CARAS 1, and 0.25 milliliters of CARAS 2 solution. The tubes were then vortexed to mix the solutions thoroughly and then centrifuged to collect the supernatant, which was then removed, and the residue was extracted 2 additional times, so basically 2 more extractions were conducted, each using 5 milliliters of 10 micrometer formic acid solutions. And then the clear extract that was eluted then eluted through a preconditioned MCX cartridge at a rate of 1 drop per second, and they made sure to discard the first 8 out of 10 drops in case there was any unwanted component still present. And basically, this cartridge contains a mixed mode polymer sorbent that can help in achieving high selectivity of the acrylamide that we're aiming to get. Okay, so for the actual analysis, it was done using a liquid chromatography mass spectrometry analysis, and the drops were used from the previous extraction. And basically what LC-MS is, it's an analytical technique that involves the physical separation of target compounds, followed by their mass charge ratio and mass-based detection, which then we can use to determine the acrylamide content. And the specific HPLC system was used for this one is Agilent, rather than the Hitachi that we had been using in the previous studies. And it was also combined and utilized along with a very selective quadruple MS detector, which is the Allegiant UltraVio triple quadruple MS detector. It's used due to its sensitivity in its ability to select specific ions. So since we're focusing on selecting the acrylamide ions, it's able to process and determine that better. And 0.1% formic acid was used as the mobile phase for this situation in this study. And then the mass to charge ratio, also known as MZ, and the dry basis of acrylamide were then determined after the data was calculated. Okay, so then the determination of sugar content, they focused on glucose, fructose, and sucrose sugar content. And it was evaluated by making a mixture containing 5 grams of the raw potato samples. It was added to a tube containing 1 milliliter CARAS 1 and 1 milliliter CARAS 2 solutions, along with the addition of 70 degrees Celsius hot water. So it would equal a total of 25 milliliters. And the tissue tear was used like seen in the previous experiments. It was used for 3 minutes to homogenize the sample. And then the sample was centrifuged for 10 minutes to separate the mixture. And the upper supernatant were filtered out using the nylon filters. And then 10 microliters of the samples were then injected into the Hitachi HPLC system. And then the refractive index detector of this system that was used helps determine the reducing sugar content of the raw potato. And the principles are similar to the other HPLC setups that we've seen in this study, along with this inclusion of the isocratic elution. And basically what an isocratic elution means is that the composition of the mobile phase and the flow rate are going to be held at a constant. The mobile phase for this experiment consisted of acetonitrile, which is a polar solvent to water ratio of 85 to 15. And then for the statistical analysis of this article, they used 3 tests. The first one being analysis of variance, or ANOVA. It's one of the most common main tests used. And it helps determine significant differences between the means of independent groups. However, it's not able to tell you which means are different. So that's why we have to use a post hoc test, like the Duncan multiple range test, which is able to tell us which means are different, and it allows us to measure specific differences between the pairs of means. And the difference range for this one was 0.05. And then for the T's test, the significant difference was measured for the effects of frying, and it also was 0.05. And then here are a few of the references that I've been using for my article analysis and used in this presentation. Thank you.